Hello students, how are you all? How are you enjoying these days? So today we are going to see the preparation method of alkanes by using alkenes and alkynes. What should we do with the alkenes and alkynes to get alkanes? So the first simple preparation method is hydrogenation. Hydrogenation of alkenes or alkynes will give you alkanes. So if you see carefully, what is meant by hydrogenation? Hydrogenation means the addition of hydrogen. Whenever multiple bonding is there in an hydrocarbon like alkene and alkyne, when we are adding hydrogen, the multiple bonding, nothing but pi bonding get broken and hydrogens get added up on the double bonded carbon atom. So we'll see that in the mechanism. First, we will see what are the reactants, what are the reagents, what are the catalysts, and what is going to be the product in hydrogenation of alkenes and alkynes. So I'm displaying a table over here. You can see students over here, alkanes preparation by hydrogenation of alkenes and alkynes. So this is the table of form which you can easily understand and you can easily remember. The first point that you need to remember over here that we are doing here is the process. The process is hydrogenation. What I told you, hydrogenation means plus of H2. So what are the reactants that you are going to take? I told you that you can take reactant alkene, you can take reactant alkyne, and you are doing hydrogenation means you are adding up hydrogen and you are going to use catalyst. What is meant by catalyst? You know about that. It is a foreign substance that you are adding to increase the rate of reaction. So that is catalyst. Now we can take so many catalysts we are having. We can take some some transition elements, mostly especially if you take nickel, platinum and palladium. These you can take, or you can take platinum oxide also. If you are taking platinum oxide, that catalyst is called as Adams catalyst. Okay, whatever catalyst it may be, you can take any catalyst and you have to maintain the temperature of 473 to 573 Kelvin. And in this reaction, the formation of alkane is obtained. Okay, formation of alkane occurs. Now, here one important point that you need to consider for your examination is, if especially nickel only is used in this reaction, then that is called as one particular name reaction, Sabatier-Sanderens. Okay, Sabatier-Sanderens reaction. So remember everyone. Now if you take in this reaction, we are taking alkenes, alkynes. You know very well, but what you know, students? Alkenes means definitely there should be a double bond between two carbons. Alkynes means there should be triple bond between carbon atom. At least one double bond, at least one triple bond. Means it is not possible to make alkane having one carbon. Why? Because you are choosing a carbon reactant which is having two carbons at least with the multiple bond. So because of that reason, methane cannot be prepared in this method. That you need to remember, everyone, students. So let's see some of the examples in next page. So if I take an example, a simple alkene which you know very well is what? CH2 double bond CH to what it is, beta? Ethene. Yeah, so you can call it as a ethylene, common name, IUPAC name is ethene, you know very, very well. Now what we are doing, we are adding up hydrogen in the presence of what? Any catalyst. I'm taking especially nickel as catalyst, students. If I take nickel as catalyst, what will happen? You know, I told you the bond cleavage will occur. Which bond will be broken? Pi bond only will be broken, and each double bonded carbon will get hydrogen. So what will happen? So CH2, one single bond, CH2, one bond is broken, and another. So each carbon atom will get one hydrogen. So this is simply, you can also write what? It is nothing but what? Ethane, CH3, CH3. It is called as ethane. Done. So can I give one more example, students? I'll give you one more example. We will solve. CH3, CH, double bond, CH2. What it is, students? It is propene. Now, what you're doing here also, you need to do hydrogenation, sir. What you catalyst you can take? Sir, I like platinum, then you take platinum. So in the presence of platinum, what is going to happen? Same thing, sir. The CH3 will remain as it is, and this CH will remain as it is. Single bond, CH2. What I told you, one bond will be broken, pi bond, one hydrogen will be over here, another hydrogen will be over here. Yes or no, students? Or you can write that CH3, CH2, CH3. What is it, students? It is propane. So like this, we can make so many examples. So we can take alkyne also. I'm giving you one better example of alkanes. Let's see, students. The first alkyne is what, beta? The first alkyne is acetylene. You can call it as a ethyne. So you can see right now over here, there are one sigma bond and two pi bonds. So because of that reason, when you are adding hydrogen, so you can write this step by step. Otherwise, you can write directly also. You can take another catalyst, palladium also you can write over here. So what will happen? So generally, one CH, double bond, another CH. Mean what happened? One bond is broken, one hydrogen is added over here, sir. Another hydrogen is added over here, sir. So addition is happening. One bond is broken, two bonds are formed. So that is addition reaction. Now there is possibility of one more possibility to add up hydrogen. So you can write hydrogen in the case of again palladium, in the presence of palladium. Then what will happen? One more hydrogen will get added up. So what will happen? CH, already hydrogen is there. So one more hydrogen is being added up. So CH3 and CH3. What you are going to get, students? Ethane. So here you can see we can prepare only, okay, we cannot prepare methane over here. So as such alkene having one single bond is not possible. Alkyne is also not possible. So this is another one preparation method. I will give you one more example, students. So let's take an example of propine CH3CH. Okay, CH3C triple bond CH. Here what you take, students? CH3C triple bond, okay, CH. This is alkyne. So here I'm writing reaction directly, students. Listen carefully. So here in this case, totally to convert ethyne into ethane, how many moles of hydrogen you have utilized? Here 1 mole, here 1 mole, totally 2 moles to break 2 bonds. So here we can write directly 2 moles of hydrogen in the presence of palladium or platinum, any catalyst which we use for hydrogenation. So directly what will happen? CH3, CH, 2CH3. So what we are going to get over here? Propane. So these are the simple methods for the preparation of alkanes. You can easily see we can't prepare methane. Now we will see mechanism. Actually, how it is happening. If you see mechanism, students, in this mechanism, how it is happening, how hydrogen is being added up, what actually is happening, we'll see that one by one. And this mechanism is not, I'm not telling that it is not important, but the thing we should have idea how it is happening. It may be the question which is given in exam also for NEET or means whatever it may be. So let's see, I'm taking, so you know very well, students, what you know very well, I'm taking a catalyst over here. You can consider it as a nickel. Here also I'm taking the same nickel. Nickel in the, you will be, you know very well, this is a transition element. So here I'm taking nickel. If you take nickel, nickel is nickel, platinum, palladium. These are having good adsorption property. When these are having good adsorption property, hydrogen can be accumulated easily. So suppose if these are the, okay, what are these? Nickel, this is also nickel, and this is also nickel. Now what is happening when you bring this very close to the hydrogen? So hydrogen slowly gets accumulated over here. Understood my point? Hydrogen get accumulated over here, means hydrogen will be like this. Over this I'm showing only this kind of one hydrogen I am taking here. Okay, you think that hydrogen is being accumulated over here. So this is called as what? Adsorption. Accumulation of a particular substance over another substance is called as hydrogenation. Adsorption. So if you see here carefully, students, what we are doing here, adsorption is occurring. Fine. Now what we need to do, our main aim is to do, hydrogenation. So I'm bringing this alkene, ethene near to the catalyst on which hydrogen is accumulated. So during this process, what will happen? It will come very close to it, and because of that reason, what will happen? There is formation of a transition state. What kind of transition state? I'll show you here. What I told you here, hydrogen was there. Here hydrogen was there. Here ethane is there. So what will happen actually? During the process, there is formation of bond and there is cleavage of bond. So here bond cleavage will occur over here, and here bond formation will occur between carbon and hydrogen. Here again bond cleavage will occur, means which bond will be broken? This bond, this pi bond will be broken, and here the bond will be formed between this. So this is called as transition state. This is called as what, student? Transition state. What is meant by transition state? It is formed during the course of reaction. It is unstable. So once this unstable substance is formed, again immediately formation of compound will occur. So what will happen? So this bond has become weak. I will show you clearly what is happening here. You know, this pi bond is broken. Okay, how many transition state is having how many atoms in between that? So it is connected to four atoms. So four-membered transition state is forming here. Four-membered transition state. Then students, now what will happen? Simply, as bond has broken, so here this surface will remaining as it is, and formation of what will happen? CH3. Why? Because there is formation of bond. Okay, this dotted line which is I am representing over here, and here it is nothing but the formation of bond. So because of that reason, formation of ethane will occur this way. Understood everyone? So this is the mechanism, and here both the hydrogens are attacking from bottom, Otherwise, you can take from the top. So that kind of addition is known as syn addition. So what kind of addition is happening here? Addition reaction it is, you know. So which kind of addition you can see, student? This is syn addition. What is meant by syn addition? Sir, if both the reacting species atoms are attacking on the reactant from the same side. Okay, hydrogen as hydrogen attacks from same side, attacks from same side. So it is called as what? Syn addition reaction. Understood, students? Okay, now let's see another example. So this is mechanism, students. Now we will see whatever the important points we have seen here. So during this process, what actually happening? The formation of bonds is occurring, and one less reactive, more reactive species converting into less reactive. You know, alkanes are called as paraffins. Why? Because these are having less reactivity, means more stability. So alkenes and alkynes are less reactive compared to, more reactive compared to alkanes. So less reactive compound is converting into more reactive compound is converting into less reactive compound. Alkene are more reactive, and alkane is less reactive, means more stable. So less stable is converting into more stable, means it is an exothermic reaction. Heat will get liberated, which is known as heat of hydrogenation. Understood, students? Now I told you that there is formation of 4-member transition state. We have also seen that syn addition reaction, adsorption is being occurring. Now rate of reaction. Now if I take alkene and alkyne, both are undergoing in reaction, then which is going to react faster? You know very well, it is a syn addition reaction. So if I take alkenes and alkynes, you know alkenes which are what kind of hybridization these are having. So each carbon, this carbon as well as this carbon, these are sp2 hybridized, means these are having planar structure. So syn addition is not that much easily possible. But if I take here CH triple bond CH, which is an alkyne, it is having both the carbons having which kind of hybridization? Both are having sp hybridization, means linear shape. So because of linear shape, the hydrogen can easily approach both the carbon atom, okay, from the same side. Because of that reason, reaction will occur easily. So that is why we are telling that rate of reaction is alkynes is greater than alkenes. Now reactivity towards hydrogenation is inversely proportional to stability. So if you take any alkene, whichever alkene is less stable, for that heat of hydrogenation will be high. Whichever alkene is more stable, for this hydrogenation will be least. For example, I will give you one of the example over here. I will give you. So what kind of example we can take over here? Suppose, students, if I am giving you over here CH2 double bond CH2, and I am giving one more example CH3 CH double bond CH2. Now if you see carefully, this carbon is called as beta carbon. Here, okay, the double bonded carbon is having beta carbon, and this beta carbon is having 3, okay, hydrogens, okay, other consider it as the alpha carbon. Though not, it is not beta carbon, it is alpha carbon, students. So if I take alpha carbon, this double bonded carbon, if you see this side, it is having only 2 hydrogens, which will not cause any effect. But methyl groups are going to cause what? Hyperconjugation. So larger the number of alpha hydrogens, larger will be the stability, and because of that reason, if you take stability adder, if I consider it as a first compound, if I consider it as a second compound, now if I take stability adder, which one is more? 2 is greater than 1. Why? Because of alpha hydrogen, larger the number of alpha hydrogen, larger will be the hyperconjugation and larger will be the stability. But heat of hydrogenation, if I take heat of hydrogenation, means the amount of energy released during the hydrogenation will be more least for stable one. So 2 will be less than 1. Understood everyone, students? Now we will see some of more examples saying what is cis, what is sin addition, how we can write. So if I take over here, I'll give you a simple cyclic compound where you can easily remember. Suppose I'm giving you this example where what is happening. This is an alkene, students. Suppose I'm giving, instead of this, I will take up another one. So for easy representation purpose. So if I take alkene, which is what it is, what is its name, students? I'll repeat again to tell students. I'll write once again. Suppose I'm taking over here. Don't consider it. Okay, I'm writing over here. So here I'm taking cyclohexene. You know very well it is cyclic as well as hexane. 6 carbons are there, but double bond is there. As it is having double bond, it is cyclohexene. So when you take cyclohexene, when you do hydrogenation in the presence of one catalyst, platinum or palladium, what I told you over here that we need to remember here, it is an addition reaction. In that addition reaction, what actually will happen? Sir, formation of bonds. One bond will be broken. This pi bond will be broken, and formation of 2 more bonds will occur. So what kind of bonds those? Sir, here attack of though both the hydrogens will occur from the same side. So if I take over here, I'm representing this way, which shows above the plane, and the other one is below the plane. Below the plane. This is okay. This is below the plane, one hydrogen. Okay. This is below the plane, one above the plane, one hydrogen. So there are 2 possibilities. I'm telling you 2 possibilities, but one will be wrong, the other one will be correct. So it indicates what? One is below the plane, one is below the plane, and this one is above the plane. Above the plane. I'm just showing you the difference between those. This is called as trans addition. Trans addition. Trans addition, and it is not going to happen. It is not going to happen. So what will happen here actually? So I'm showing you the difference. That's that thing which we need to remember. So here same reaction I'm writing, but what is happening here? I told you sin addition means okay, both should be either above the plane, or both should be from below the plane. So this is called as cyclohexane. You can write the reaction this way. Okay. Otherwise, we can take in another way. What is that, students? I can take both the thick line, which indicates both are above the plane. Thick lines indicates above the plane. Dotted line indicates below the plane. So both are correct only. So you can take this one or this one depending on the question given in the NEET or JEE Mains. So carefully, students, be careful when you are trying to learn something. Try to go deeply so that whatever kind of question will be given, we can easily answer. So that's all for the day, students. Let's see, okay, next preparation in our next video.